Go, we got things to do. Things to do, things to do, people to see, things to do. All right, sums and difference formulas. This is easy. We kind of learned about it a little on Friday. You got to find the formula from your reference sheet and match it up. This first one over here, expressed as one angle. Check it out. It's cos, cos, minus sine, sine. Go look on your reference sheet, Christine. Christine? Notes from yesterday. Yeah, cos A plus B. Very nice. Christine, if I had an extra sheet, I would give it to you. So that's going to be cos 20 plus 80, which is the same thing as cos 1 hundo. Hyundai. Great cars. Okay. Anyways, that's what we do. Do you get it? Easy piece of cake. Good. I'm talking for a minute. What somebody in the other class asked about that. What about the sine? If you have your reference sheet that I just gave to you, take it out. Okay. Look on your sheet. This big long formula over here converts into this, which is then just that. And that's how we do it. That's how we do it. Now take a look at the second one, right? The second one looks really hard. I can't do that. Guess what step 1 is? Yeah, convert to degrees. Convert this bad boy to degrees. What's pi over 2? Ah, nice. What's pi divided by 6? Good. Cos 30 plus sine 90 sine 30. So then you're going to go look up on your chart. Where can I find cos plus sine sine? Cos plus sine sine. It's cos A minus B. So that's the same thing as the cosine of 90 minus 30. 90 minus 30 is 60. But then here's the problem. Who can guess what the problem is? Yeah, the original problem was written in radians. We solved it in degrees. You just have to translate back. Good. Pi over 4. No way. No how. Pi over 3. That's it. That's how we do it. So let's continue on. Let's continue on. Here we go. Now I'm going to ask you to find the exact value of certain degree amounts that are absolutely impossible to do in your calculator, but we could use the formula on the sheet. That functions of a sum of two angles and functions of the difference of two angles. Yeah, on Friday I asked you, our lesson began with me putting down a bunch of like degree amounts that were relatively important, okay? You don't have to memorize them. The ones you do have to memorize come off the chart. Give me some degree amounts that are important. 45, 30, 60. Yeah, and let me give you an example. Some other multiples of these are also important. Like, what else? 270. What else? 180, 360. How about 120? Yeah, 120 is important because it's got a reference of 60. How about 150? Reference of 30. How about 210? Yeah. Also, in any event, you can kind of see what I'm talking about in your head, right? Okay, so here's the deal. Sine of 15 degrees. Take any of those degree amounts you want, and somehow we have to find a way to either add or subtract them and get 15. Give me 2 degree amounts that you know of from the chart that you could either... That'll work. 30 and 45. What else? Anybody else? 225 and 210 will work. Give me some other ones. 360, 345. How about 60 and 45? Right? So pick 2 that you want to use. Let's do this. 45 and 30, that's cool. Now this is made up. There's lots of different ways. I'm going to use 45 and 30, and I'm going to use one of the equations from the front. I'm going to say that the sine of, you know what? That's too close. It's too close. Too close. The sine of 45 minus 30, because that will create 15, is the same thing as sine 45 cos 30 minus cos 45 sine 30. All I did was pull it off the table in the front. It's a piece of cake, that's it. Okay, let's go. So here we go. Now we're going to take all of our known angles that I asked you to memorize, and we're going to plug them in. What's the sine of 45? Nah, chill. Sine of 45. 7071, which is rad 2 over 2. What's the cos of 30? What? Radical 3 over 2. You absolutely must have those memorized at this point. Cos of 45 happens to be radical 2 over 2. Use your calculator. Sine of 30 is a half. That's how I did it. From here, you're just going to multiply. Top times top, bottom times bottom. Square root 2 times square root 3 is square root 6 over 4 minus square root 2 over 4. And then you just subtract them up. Square root 6 minus square root 2 all over 4. We're done. That's it. Nope. No way. Do me a favor. You can always check this out if you want to try and do it. What is the square root of 5 minus the square root of 3? Oh, really? Just type it into your calculator. Square root 5 minus square root 3. It has to equal the same number as the square root of 2 if that's what you're going to write down. Yeah, it doesn't work out. Your theory fails. And so here's the rule. Somebody in the other class goes, how do I know where to stop? How do I know where to stop? On your Regents exam for this particular class, if you are unsure of what to do after a certain point, stop there. Stop. Because if you just start making stuff up, we're going to take off points for everything that you make up. Okay? All right. And we're moving. And we're moving. You know, that is incredibly annoying. It's almost obnoxious of them, right? It's like, why? This class is so hard to begin with. Okay, Lil, what do we do? Yep. Nice. So this is really 165. This really is just 165. Yeah. You sub 180 in for pi. 11 times 180 divided by 12 is 165. That's also a huge part of your test, converting between degrees and radians. All right. Same style as before. Give me some numbers that you know of, some degree amounts that might add to be 165. 140, no, that's close. That's close. 140 won't do it. No. Yeah, 120 and 45 will do it. Because 120 has a reference angle of 60. Yeah. Okay, so let's do this. The cosine of 120 plus 45. So that's cos 120, bless you, cos 45 minus, What do we do? You just plug that in. Use your calculator now. What is cos 120? Good. Let's keep going. Cos 45. Radical 2 over 2. Sine 120. Plug that into your calculator. Good. Yep. What's up? Only underneath the radical if there's an I. If the number underneath the radical is negative, then that's how it produces an I. There you go. Ultimately, we're going to get negative the square root of 2 minus the square root of 6, all divided by 4. Final answer. That's it. That's the deal. And finally, the last part. The last thing that we're going to learn today. This is what your part 2 question, your short answer question looks like on your test. And speaking of your test, I took the short answer questions directly from the Regents themselves. If you have a green book and you've purchased it, all you need to do is look through the green book for something that might look like this. And that's going to be the short answer question on your test on Thursday. Okay, if you don't have your green book, it's okay, but you're going to have to use the internet to go and find it. That's what we're going to practice now. 2 problems just like it. You ready? Here we go. First thing we got to do is it's appearing to ask us how much sine A plus B is. So look up in the front of the book. Look up on your reference sheet the formula for it. Let's see if we have all the information, because this seems awfully suspicious. Seems awfully suspicious. Plus cos A, cos B. Right? Did I fill it out correctly? Now here's what we're going to do. Okay, let's check off the stuff that we've got. We know how much sine A is. That's true. Oh, that's the ugliest check I've ever seen. We know how much... Oh, made a mistake. Made a mistake. Made a mistake. This is cos A sine B. And so let's check off all the stuff that we have. Sine B we have, and then we're screwed because we don't know how much this is, and we don't know how much this is. Mick, in answer to your questions, in some instances, you could take the inverse. In most instances, it's not going to work out like that for you. I'll show you. You try and do it your way, and then you see if you get the same answer as us, and then we could talk about all the little problems that occur. All right? Otherwise, 6-point question. So hold on one second. So we have it's telling us angle A and angle B lie in quadrant 1. All right. Well, maybe that helps us out. Actually, it does, because we're going to draw in angle A and angle B and then try and figure out the missing information that we need. Angle A, angle B. Angle B is in the house tonight. No, he's not? No? Oh, boo. Okay. Angle B. Don't worry, angle B. Angle A was in quadrant 1. It literally said that in the directions. So I'm going to draw in angle A. Literally. Using the bow tie. It also told us that the sine of angle A was 1/2. Opposite side, hypotenuse. And then we're going to use our old friend. This is a very long problem. Oh, if you're really good and you have the Pythagorean triples memorized, then you could just say, oh, x is the square root of 3. Otherwise, you have to use this famous theorem. Pythagorean Theorem, from the greatest plagiarist of all time. You know he didn't even invent that. Plagiarized it and got credit for it. Was known well before. Was known well before. So x is the square root of 3. That's awesome, because now the missing piece of information that we needed from this triangle, right? What were we missing from it? The cosine of A. The cosine of A is simply rad 3 over 2. That's awesome. Guys, we got to go and do this. We got to go and do this for angle B and do the same thing. The same thing. Let's see if I could draw it in. For angle B, right? There is B right here. Okay? Sine is 4 over 5. It tells us this in the directions on top that you wrote down. Okay? And it's not going so well while we're in dual screen, so I'm going to go back to this. 5, 4, and then somebody else will say, okay, that's a very, yeah, the last side has got to be, this side over here has got to be 3, but I'm going to do it the long way just to show you that, it can be done. X squared plus 16 equals 25. X squared equals 9, and x is going to be equal to 3. And this is absolutely, amazingly fantastic. You know why? I'll tell you why. Because you were missing the cosine of b, and now we know that the cosine of b is how much? It's not just 3. 3 over 5. It's 3 over 5. Now, what do you do with all this info? You plug it all back in to this formula right here, right? The sine of a plus b is now equal to, sine a is a half, cos b 3/5, cos a, grad 3 over 2, and sine b was how much? So here we go. This is going to be 3 over 10 plus 4 square root 3 over 10. And so therefore it equals, final answer, 3 plus 4 square root 3 all over 10. It's crazy. Nah. 6-point question. A lot of points on the most recent exam. Guys, we have 7 minutes. 7 minutes. I'm killing this problem in 7 minutes. That's what we're doing. You know what I'm saying? 7 minutes to go. Ooh, time flies. Cos x minus y. Uh-oh. You are going to college. Whoops. Sine y. Sine y. Let's just see what we got. We've got this one. Nice. Sine x. We got this one. Uh-oh. We're screwed. But not really, because guess what we're going to do? Draw up the triangles, find the missing sides, find the missing stuff, plug it back in, and then we're done. Guys, we got 4 minutes. 4 minutes and we're out of here. Come on, we could do this in 4 minutes. We could do this in 4 minutes. Come on now. 4 minutes and we're out of here. 4 minutes. What quadrant, Luna, did it say angle X was in? 1 or 2? Good. Angle X was in quadrant 1. What do we know about angle X? It's the sine. So this side opposite is 12. This side hypotenuse is 13. And then, of course, now I'm not going to use an X because it's already filled in. I'm going to use an A in honor of Pythagorean Theorem. A squared plus B squared equals C squared. Yeah, it's 5 if you memorized them from back in middle school. I'm sorry. A squared plus 144 equals 169. A squared equals 25. A is going to be equal to 5. You're about to find out why it matters. So therefore, what do we know? We happen to know that the cosine of x, that's the deal, Lil. The cosine of x is 5 over 13. Now we're going to do the same exact thing. We're going to do the same exact thing for the other one. Whoops. Let's go back. Let's do it up. This is angle y, right? Draw it in. What quadrant did it say it was in? So you got to draw it in. Now what does it say? Is it the cosine of y? The cosine of y, it said, was negative 4/5. That's negative 4. How could the line segment of a triangle be negative? Because it's in this quadrant, and all the x values over here on that line are what? Are negative. That's why it's negative 4. Which one was this one? 5, of course. Now, what is this last side? Of course it's 3, but yeah, it's positive because it's going up. Very nice, Lil. 4 squared plus b squared equals 5 squared. 16 plus b squared equals 25. Whoops. Whoops. So b squared equals 9, and b is going to be equal to 3. Nice. How does that hook us up? How does that help us out? Because now you know that the what? The sine of y is what? Yeah, 3/5. Piece of cake, right? You did all that work, and I'm sorry I'm going so fast. You did all that work to finally get down to the fact that the cosine of x minus y is this. We're just subbing them in. What did the cosine of x turn out to be? 5/13. Hopefully this computer doesn't mess up. I knew it would. That sucks. No, it'll be fun. It'll be fun. Hopefully it'll. Okay. So it's 5/13. What's the other one? My perfectionist killed me. We're not going to finish now on time. 5/13. This is 3/5. What's the next one? Very nice. What about the last one? What's up? Don't leave. Do not pack up and leave. So let's fill this out. Let's fill it out correctly. Let's finish the problem. Okay? So what is the first one? What is the cosine of x? Okay, so this one was right. This is okay, and this one is negative 4/5. And what's this one? 12/13. And this is 3/5. Multiply them, condense them down. I think you're going to get that this is over 65 plus 36/65. You know what the final answer is? 16/65. That's it. We did it. We made it.